Okay. Oh, I have it in the wrong thing. There we go. All right, so this is day 7, figure preserving, well, excuse me, figure preserving series of rotation and reflection. So what's going to happen in this day and in the next few days is that we're going to be talking about transformation. So is going to be a little bit of vocabulary at the very beginning. But what we learned today, we're going to use it on for the next few days. So this is just a basic idea of what transformations is going to be about. So in art and design, we see objects rotated to different positions to enhance visual appearance. We see reflections on objects in water, in a mirror, and in glass to form images. In this lesson, we are going to discuss figure preserving series of rotations and reflections where the image is mapped onto a pre-image. So the basic idea is that the size does not change. It's just where the object is at that's changing. So a map figure is mapped onto itself when a series of transformations results in the original object. Let me see if I can get rid of this. Obviously not. Okay, so it wants to say there. All right, so transformations. A transformation is a change in either size, position, shape, or both on a plane figure. Conventionally, we name images using the adding of this symbol right here to add letters used to name the pre-image. So if we have an image, let's say ABC, the next image would also be ABC, but it would have A with this symbol, B with this, and C with this. Rotation is a transformation which turns a plane figure about a fixed point called the center of rotation. So rotation is just turning it. So turning, 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 just like my arrow is turning in a circle. So rotation, think of a clock. Reflection. Sorry about that, guys. So transformation, we just talked about that. Rotation, we just talked about that. Reflection is a transformation where a plane figure is reflected about a line called the line of reflection or the mirror line to form an image. So if you guys would like to pause this at this point, I would pause it, copy it down. Remember, you don't have to copy down everything word for word, just a basic idea. Moving on. So an image, the figure that results from a transformation. So this is the after image. The pre-image is the original figure that has not been transformed, also called the object. The midpoint is a point exactly at the center of a line segment that divides a segment into two equal segments. So if this was, say for instance, this line right here where all the text is at, the midpoint would be about where the R is at. So that's the middle between A and T. That R looks about the middle. So again, copy this down, pause the video at this point. So rotation. In rotation, the center of rotation is fixed while every other point on the preimage is turned about a fixed point, called the center of rotation. A plane figure can be rotated about its center until it fits onto itself. This can occur 2 or more times in one turn depending on the shape of the figure. One turn is equivalent to 360 degrees. So, for instance, if I have a rectangle, I can turn it around twice for it to get back to its original spot. So a figure can be rotated either clockwise or anti-clockwise or counterclockwise. I don't know why I wrote anti. The clockwise rotation is a rotation in negative angle direction, while anti-clockwise rotation is in the positive. Again, pause, sorry, pause. Really, I don't feel like you need this information too much. Maybe these points right here, these two bold points, but other than that, this part, it doesn't really matter. So a rotation that maps a rectangle onto itself. So we'll see a rectangle here. So the rectangle below, we can come up with a series of rotations that map it onto itself. We first locate its center O, so here's the O, here's the middle, drawing the diagonal. So if I draw a line from A to C and D to B, it lets me know that this point where they both meet is going to be the center of this rectangle. And it's also the center of this line and the center of that line. All right? So copy down the figure that you guys see. All right? So there's line AC and BD and point O right there in the middle. Sorry, copy that down. Good? All right. We rotate the rectangle clockwise through an angle of 90 degrees about the center. The series of rotation is shown below. So here is the picture I had before. I'm going to take my pencil, put it where this O is at, and I'm going to turn it clockwise. So it's going to go to the right. So once you do that, it should look like this, where the AB are on the top and the DC are on the bottom. The O didn't move. It's just everything else turned on its side. Copy that down. So again, you don't have to copy this part other than 90-degree angles, but you would draw, this is already drawn. You would draw an arrow going this way, and you would draw this part right here. So this is already drawn from before. Draw an arrow next to it, and then draw this to show 90 degrees. You're going to be doing that a couple of times. So we're going to rotate it 180 degrees. So it's 90 from where we left off. So this was 90 degrees. If we do that one more time, so turning it again 90 degrees to the right or to the left, so we're going as a clock, we would get it like this, which is the original, so the pre-image, upside down basically. So AB are on the side and CD are on the side. The O is still going to stay in the middle. So again, you already copied this down. Draw an arrow next to it or like under it or something. Draw 90 degrees and then show where your A, B, C, and D are. And make sure you're labeling it because then you won't see the difference. Copy it down before I turn over. And turning. So the image formed is mapped onto the object. All right, so if we continue rotating it for another 90 degrees, so that's a total of 270. So this is where we left off. If we turn it again 90 degrees, it would be looking like this. Oops. So AD, DC, CB, AB. Copy it down. And moving on. If we rotate it one more time, so this is where we left off, if we do it 90 degrees more, we get back to the original spot. So you kind of should have a circle of what's going on. copy that last box down. Moving on. Oh, so this maps the image onto the pre-image again. We now discover that after a rotation of 180 and 360 about its center, the rectangle is mapped exactly onto itself. It fits into itself twice in a rotation of 360. So for instance, if we go back, this is how it looks. After 90 degrees, it moved. It's now up and down. But if I turn it again, it looks like it did before. So it got, like if I would take this image and move it to the first one, it would look just the same. It would be able to fit on top of each other. And if I do that one more time, it's up and down again. But if I do it one last time, it goes back to its original spot again. So that's what we're talking about. So did you have to copy this? Probably the first sentence, if that, maybe the two. This is only effective when it comes to rectangles and some other ones, but it's not 100% necessary for you to copy this one down. Alright, so the last part when it comes to rotation is going to be about regular polygons. So a polygon can be any figure that has the same, all angles and all sides are equal. We can determine the angle of rotation about the center of any regular polygon by performing this formula. So 360 degrees is going in a full circle. N is the number of sides the polygon has. So we are going to do, so see, where N is the number of sides of the polygon. So the only thing on this slide that needs to be copied down is a formula, 360 degrees divided by N, and the sentence where N is the number of slides. So copy that, pause the video, and move on. A rotation that maps, okay, so a hexagon has 6 sides, and therefore the angle of rotation will be 360 divided by 6 because it has 6 sides. So the angle of rotation is going to be 60 degrees. So it needs to move 60 degrees. So multiples of 60, so 60, 120, 180, and then back to 360 is when you're going to have the hexagon match itself again. So it's going to move on the same spot. And that works for both counterclockwise and clockwise. So on here, I would write down this sentence right here. A hexagon has 6 sides. I would write the formula. And then this last sentence right here. So the hexagon will be mapped onto itself in a series of rotations at intervals of 60, either clockwise or counterclockwise. Pause the video. Moving forward.